Hi everyone, in this video we will be talking about the mole and molar masses or the molar mass of compounds. We have already started talking about the atomic masses for each element as reflected in the periodic table. Now, this time we'll be talking about the mole, which is practically the SI unit for the amount of chemical substance. So it is the amount of substance that contains the same amount of atoms in exactly 12.0 grams of carbon 12. So this 12.0 grams of carbon 12 has been our standard for the mole. Now, take note that the mole represents the number of items in Avogadro's number, which is 6.022 times 10 to the power of 23. And that 1 mole of items is equal to 6.022 times 10 to the 23rd items, in as much as 1 dozen of items is equal to 12 items. All right? The abbreviation for the mole is MOL. And when you talk about molar masses, this is the mass in grams of 1 mole of an element, compound, or molecule. So the unit is grams per mole, and for elements, the molar mass is numerically equal to the atomic mass. And for compounds, the molar mass is the sum of the atomic masses of component elements. Now, compounds with the same number of moles contain the same number of particles. So, for example, if you have 1 mole of silver atoms, 1 mole Ag, that means there are 6.022 times 10 to the power of 23 silver atoms. And if you have 1 mole of silver chloride, then that means that there are 6.022 times 10 to the power of 23 silver chloride formula units, okay, or compounds of silver chloride. Now again, the atomic mass is numerically equal to the molar mass. So for example, here you have carbon, which has an atomic mass of 12.01 mu. Then therefore, 1 mole of carbon is equal to 12.01 grams per mole. Okay, it has the mass of the molar mass of 12.01 grams per mole. The same thing with oxygen, okay, from 16.00 mu, that's atomic mass. So if we are going to talk about the molar mass of oxygen, then that's 16.00 grams per mole. Okay, now take note that each element has its own unique molar mass. Now, there are different terminologies also as regards molar mass, okay, or in terms of the masses of substances. So here are a few additional key terms. When you talk of molecular mass, abbreviated as mm, then it is the sum of the atomic masses of all atoms in a molecule of the substance, okay? While for formula mass, then that's the sum of the atomic masses of all atoms in a formula unit of a compound, whether it is molecular or not, right? So formula mass can either pertain to the mass, okay, the sum of the atomic masses of molecules or of ionic compound. Okay, now the molecular mass only pertains to the sum of atomic masses for a molecule only, right? And then we already know what a mole is and the molar mass. So again, for all substances, the molar mass in grams per mole is numerically equal to the formula mass in atomic mass units. Okay, and so here are a few examples that we have. Okay, let's make it a little bit larger. So we are asked to solve for the molecular mass or formula masses of the following compounds. So for example, you have iron 2 sulfate. So the first thing that we have to do is identify what elements are present or are involved in the compound. And then after that one, we are going to use the periodic table to determine their atomic masses. And then after that, we are going to multiply it with the number of atoms and get the total for each element. Okay, get the total of all atomic masses. So for example, we have iron 2 sulfate. So you already know why this is iron 2 sulfate. This is a product of Fe plus 2 and then SO4 2 minus, so that when you crisscross and disregard the sign, the 2 supposedly gets cancelled out, or the compound has been in a way reduced to its lowest terms. Alright, so once you have Fe now, the atomic mass for Fe is 55.85. Okay, now by convention, let us just round off the atomic masses into the second decimal place. All right, so this is atomic mass represented by the Greek letter mu. And then there is also sulfur, okay, which has a mass of 32.07. Okay, that's our mass for sulfur. That's mu also. And then for oxygen, then take note that in the formula we have 4 atoms of oxygen. So we take that into account. That's 4 times 16.00. Those are the number of moles, or the number of atomic mass units for oxygen. Okay, and once we get the total, we have 55.85 plus 32.07 plus 4 times 16. And then we end up with 151.92 atomic mass units, right? So this is our formula mass for iron 2 sulfate. That's 151.92 atomic mass units. If you are going to report this as the molar mass of iron 2 sulfate, remember that they are just numerically equal. Okay, the molar mass of a compound is numerically equal to its formula mass. So therefore, if you have mm, this time it speaks of the molar mass, mmSeFeSO4, then we have 151.92. Then instead of mu, then we give it the unit of grams per mole. All right? So meaning to say, there for 1 mole of iron 2 sulfate, then its mass is 151.92. All right? Now let's have the other example. This one is NH4 2SO4. So this is, take note, the ammonium ion, and then this is the sulfate ion. Okay, so this is a result of the reaction between ammonium ion, NH4 plus, and SO4 2 minus. So again, we take into account all the elements present. You have N, H, and then S, O. Alright, now for those of you who have mastered this already, then no need to list down the elements, but I'm trying to do this step by step. Alright, now take note that you have 2 groups of the ammonium ion. So this subscript here represents that there are 2 ammonium ion in that particular compound. So therefore, we have to multiply it with 2. Then we know that the atomic mass of nitrogen, if you look at it in the periodic table, is 14.01 mu. All right, and then hydrogen, there are 2 times 4, so it's just like distributing 2 to each subscript. So 2 times 4, you get 8. Okay, and then 8, the atomic mass for hydrogen is 1.01 mu. Then for sulfur, we have, as in the previous example, 32.04 mu. And then for oxygen, there are 4 oxygen atoms, and multiply it by 16, which is the atomic mass for oxygen. All right. So we are just going to perform the necessary operation. So that means you'll have to multiply 2 times 14.01 and then 8 plus 8 times 1.01 plus 32.04 plus 4 times 16.0, and then we end up with a grand total of 132.0.14 atomic mass units. So this is now the formula mass for ammonium sulfate. Okay, ammonium sulfate is an ionic compound made up of the ammonium ion and the sulfate ion. And so therefore, the molar mass of ammonium sulfate, okay, in this abbreviation, we are talking about the molar mass and then not the molecular one, although they may have the same abbreviations. So this is 132.14 grams per mole. All right. So in some textbooks, they also like to write, okay, the whole formula to really specify NH4, then sub 2 SO4. Okay. Also on at the bottom, NH4 sub 2 SO4, right? But we can stick with grams per mole, just like in the first example. All right, so this is practically useful when we carry out chemical conversions already, or mole conversions, and in stoichiometric calculations. So either way, we can just stick with 132.14 grams per mole. All right. Now, in our next example, we have a molecule. This is the glucose molecule. So, again, we account for all the number of atoms as well as their masses. So I have carbon, I have hydrogen, and I have oxygen. So this means in the formula, we have 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. The atomic mass for carbon is 12.01 mu, and then for hydrogen we have 1.01 mu as well, and then for oxygen we have 6 times 16. Now you notice that this is a product of non-metals that are bonding, so practically we are looking for the molecular mass of glucose. Okay, so this is the glucose molecule. And so what we have here is 6 times 12.01 plus 12 times 1.01 plus 6 times 16, which gives us a total of 180.18 atomic mass units. So we'll write it down here. This is 180.18 mass units. And so if we talk about the molar mass of glucose, of C6H12O6, okay, then we can just say that it has 180 rather, 180.18 grams of glucose per mole of glucose. Right? So that's our final answer. Now our last example is a hydrate. Okay, so it is an ionic compound with water molecules attached to it. So you might have noticed that there's a dot between these two two formulas. So it's just like saying that five water molecules are attached to the copper sulfate. So what we are going to do here is just add the atomic masses or the formula masses for both copper sulfate and the water molecule. So here we have copper, Cu, and then SO4. So oxygen has four, sulfur has one, copper has one atom. Then if you try to look at the atomic mass of copper, then that is 63.55 atomic mass units, while for sulfur you have 32.04 atomic mass units. And then for oxygen you have 16.0 atomic mass units. Okay, and then you also take into account water, so you have H and then oxygen. Now take note that the coefficient beside the formula for water represents how many groups of water there are, or how many water molecules there are. So we must also take that into account. So since it has 5 here, it has 5 as its coefficient, then we also multiply 5 to the subscript. So therefore, all in all, we have 10 hydrogen molecules, and the atomic mass of hydrogen is 1.01, right? And then oxygen, so we distribute 5 here. There are also 5 oxygen atoms, okay? Because there are 5 water molecules, and then 16 mu. So what we are going to do now is to get the total for each atomic mass. You get the total of the atomic masses for both copper sulfate and the 5 molecules of water. So for the copper sulfate, I have 1 times 63.55 and then plus 32.04 plus 4 times 16. I have a subtotal of 159.59 atomic mass units. Now what we are going to do is add it to water. So that is 10 times 1.01 plus 5 times 16. So all in all, we have for the 5 molecules of water, we have the molecular mass of 90.1 AMU. All right. So in order to get the formula mass for this compound, we have to add everything up. So that's 90.1 plus 159.59. We have a grand total of 249.69 formula mass units or atomic mass units, or we can just report this directly as 249.69 grams per mole, right? If we are asked to get the molar mass. So usually we are asked to get the molar mass of substances in solving stoichiometric problems. All right. Now the name for this compound, by the way, is copper 2 sulfate. Copper 2 sulfate pentahydrate. So there are 5 water molecules. So we attach the Greek prefix penta, okay, 5 for penta, so copper sulfate pentahydrate. Now there are also some compounds which have, for example, 7 or 10 attached water molecules, so those are still hydrates, but if it's 7, we have now the name heptahydrate, while for 10 we have decahydrate. So the number here, the number that we use for the number of atoms actually changes as well. All right, so be mindful of this coefficient here, especially if you have hydrates. All right, So that ends the examples or discussion of examples for molar mass.